Welcome to the lecture course CHO 351 for MSc-II organic class. In previous lecture, we have discussed about the mass fragmentation in alkane, cycloalkene. In this lecture, we are going to discuss mass fragmentation in alkene and cycloalkene compound. So, firstly, mass fragmentation in alkene. So, in alkene, molecular identity is strong. Also, we can observe the MAC Lafferty rearrangement when gamma hydrogen is present. Gamma hydrogen is present at time MAC Lafferty rearrangement is also observed in mass fragmentation of alkene compound. Series of peak like M-50, M-29, M-43, M-57, etc. so on. So these peaks we can observe in alkene mass fragmentation. So let us discuss with example. For example, one painting so bombarded with electron. So in alkene, pi electron is present. That pi electron is loosely bound, you know very well. After bombarding, this loosely bound pi electron is removed from alkene, and there is a formation of molecular ion peak. We write it like this. Molecular ion peak we can represent like this. So this is molecular ion peak observed at mass to charge ratio. So you have to count the number of carbon here. 5 carbon is present, and to this, what is it, 10 hydrogens. So 12 into 5 plus 10. So molecular weight of this compound come out to be 7. So this molecular ion peak come out at mass to charge ratio 71. Okay. After this, you know that very well. So this strong molecular ion peak, after this molecular ion peak undergo fragmentations. So after this, we can observe the first peak here because loss of methyl group. Okay. Then loss of 79 means ethyl group. Methyl group, ethyl group. So when this group is lost as a radical, so we get the first peak, and after loss of this group we get the this peak. So firstly, 1, 2, 3 and 4, we get this peak with loss of methyl as a radical. Okay. Next is a ethyl as a radical. Okay. M minus 50. So 70 minus 50. So this peak come out at mass to charge ratio 55. Okay. While this M minus 29 means 70 minus 29. So this peak come out at 70 minus 29. So nothing but 41. So this peak is the best peak. Best peak is nothing but most intense peak in mass spectrum. So this peak is the most intense. Why? Because this cation is well stabilized by resonance. So this kind of peak we can observe in mass fragmentation of this alkene, means 120. Also remember that in this compound alpha, beta and gamma hydrogen is available. So this compound undergo McLafferty rearrangement, means 120. So how see here? So I represent this molecular ion peak in this way. This is a radical, this is a positive charge. Okay. This alpha, beta and gamma hydrogen. Okay. So this is the molecular ion peak. We can represent also like this. So these two are equal at the same mass to charge ratio, that is the 70 value. So after this gamma hydrogen is attracted to this carbon. Okay, so these two bonds form here. Same time, what happened here? Bond between alpha and beta is break here. So this electron is transfer here. Same way this electron is transfer here. Same time this electron is transfer here to the alpha carbon. So bond between alpha and beta is break here, and because of that we get the here M minus 28 peak, means loss of equilibrium means M minus 28. So after that this become methyl group here, CH3. Then this is a CH positive, and this is nothing but alpha carbonate, CH2 radical alpha carbonate. So with loss of equilibrium like this. So CH2 and CH2. This is the beta and gamma. Okay. So M minus 28. So mass to charge ratio we get this peak at the value 56. Right? 70 minus 28. So that value 70 minus 28. This value come out to be 42. So at this value we get this peak. So radical and positive charge. So because of McLafferty rearrangement we get this kind of peak. So this is about the 120. Next example we are going to consider here, that is the 2-hexene. Suppose hexene. Okay. So this compound when bombarded with electron, after bombarding with electron, we can observe the molecular ion peak. After bombarding with electron, we can observe the molecular ion peak at mass to charge ratio. So molecular ion peak at mass to charge ratio, that is the 84. At this value we can observe the molecular ion peak. So here same like above molecules. So M minus 50, then M minus 29. So after loss of M minus 50, we can observe it like this. With loss of methyl as a radical. So 1, 2, 3, 4, and 5 here carbon. So mass to charge ratio is you can observe 84 minus 50. So 84 minus 50. So 69, that is when we can observe this peak. Also 29. Loss of methyl group as a radical. So this group as a radical. So carbon number 4 carries the positive charge with loss of ethyl as a radical. So this peak we can observe at mass to charge ratio 84 minus 29. So this value come out to be 55. So at this value we can observe this peak 55. So this kind of peak we can observe in 2 Also here there is a MAC-40 rearrangement is possible. MAC-40, why MAC-40 is here? Same like above molecule we can show here. One, two, three, 4, 5 and 6. So alpha, beta and gamma. This gamma hydrogen is available here. So radical, this is the positive charge here. So this is the molecular ion peak. We represent like this. Mass to charge ratio 84. M minus 28. So like this. So because of MAC-40 rearrangement, so like this. So we get the M minus 28 is 84 minus 28, 84 minus 28, that is nothing but so this peak we can observe at mass to charge ratio 56 after loss of each linear molecule. Gamma and beta and alpha and beta bond is break here. So this alpha bond here. So we can observe this kind of MAC-40 rearrangement in 2 So remember that strong molecular ion peak with series of peak like M minus 50, M minus 29. So this kind of peak we can observe in alkene molecule. So this is all about the mass fragmentation in alkene. So next is the mass fragmentation in cycloalkene. Mass fragmentation in cycloalkene. So when double bond is present in cyclic ring, means cycloalkene, so cycloalkene compound undergo retro this under characteristics reaction during the mass fragmentation of cycloalkene. So like this, suppose I consider the examples of cyclohexene. Okay. So this cyclohexene, when bombarded with electron, So we can observe the molecular ion peak like this. So molecular ion peak mass to charge ratio 82. So at this value we can observe the molecular ion peak. So after this I have told that this compound, cycloalkene compound, show the characteristics mass fragmentation, that is the retro-disorder reaction. You know the retro-disorder reaction. In retro-disorder reaction, there is a simultaneously breaking of two sigma bond and the loss of M minus 28 means loss of ethylene molecules. So M minus 28 we can observe in that. So like this. So loss of ethylene, this part is the loss of ethylene like this. So 1, 2, loss of ethylene with you can observe this M minus 28 is nothing but 82 minus 28. So this peak we can observe at the value 54. So this kind of peak means peak at mass to charge ratio. Peak at mass to charge ratio 54 indicate that compound is a cycloalkene. In that this compound under the mass fragmentation, that is retro-disorder reaction, is occur, and because of that we can observe this kind of peak in mass fragmentation. So this is all about the mass fragmentation in alkene and cycloalkene. So in next lecture we will discuss about the mass fragmentation in alkyne and aromatic hydrocarbons.